Hello everyone, welcome to Module 2, Sets and Whole Numbers, Number Theory, and Numerations and Computations. So all number theory really is just the study of positive whole numbers and computations, like how we are using those numbers, what we're doing, the operation we're performing to the numbers. So let's go ahead and get right into it with question 1. And it says, let U equal this, let A equal this, B equal this, C equal this. And we're going to use the Venn diagram to show all the elements of U, which is what this is called. And then we're going to list all the elements to the following sets. So for A, it says B union C. And all union means is everything that B has and everything that C has combined. So if we take a look at that, I'm going to circle C, circle B. And so everything that B has and C has. So all we have to do is write down the letters that are in each of those circles. So we are going to do F, A, D, E. That looks a little crazy, but so that's everything that B has, everything that C has. So you can see here and here, everything they have in common. So now we're going to do another one. And this one says B intersect C. So the upside down U just means where do they intersect at? Well, an intersection is where they cross. So if we look at these circles again, whoops. If we look at these circles again, we can see that where they cross is going to be right here, A and D. And that's all there is to that one, which is pretty simple because all we have to do is look at where they're crossing paths. So now we're going to look at A union C. So for this one, again, it's just like A up here. These are really similar, except we're using a different circle. So we have A, and then we have C. And what we're going to be doing is combining everything they have in common. So what that is going to be is A, B, C, D, as well as E. So we see A, B, C, D, E. And the F is over here in B, so that's not a part of this. So now we're going to move on to part E. I know it sounds kind of confusing saying all the letters because they're on the Venn diagram and they're also representing each problem that we're doing. But anyway, so this says A and it has a little line on top of it. And think of the little line on top of A as like a minus sign. So what this translates to is everything except A. So what we're going to do is exactly that, everything in the circles except A. So what that's going to be is we're going to exclude this. So it's going to be F, G, and H. So everything else is, represented by the A circle. So that's what that one's going to be. So moving on to our very last one. What we're going to do here is A union, in parentheses, B intersection C. Now this seems kind of confusing at first, but when we think about some of the rules in math, we know that the parentheses are what we always do first. So if we just start with the parentheses, this will make this problem a lot more easier. So we're going to do B intersection C. And again, that means where do B and C intersect? So we can tell that from previous problems that B and C are going to intersect right here at AD. So we're going to put AD parentheses. And then for the A union, we're going to list everything that is an A. So we're combining both of the concepts, union and intersection. So we just did the intersection, now we're going to do the union. So everything that would be an A would be B, C, E, D, and A. I'm going to start that over. I'm going to erase some of this right here. So that's B, C, D, E, and A. There's not much, I'm running out of room over here. But basically, you know, all these letters trying to figure out is just trying to help us understand what union means and what intersection means. So union means everything that they have, and intersection means where do these paths intersect. So moving on to question 2, it says let C, H, and T denote the sets of circular, hexagonal, and triangular shapes respectively. Let S, L, and R and B denote the sets of small, large, red, and blue shapes respectively. The set A contains the shapes that are small and not triangle, so A equals S in T. Complete parts A through D. Okay, so what we're going to do here is, this seems a little confusing, but once we read the instructions, it's not too bad. So we have red, we have blue shapes, and all these shapes are either small or large. So we have to come up with a statement based off of what we're given here. So we see that here it says, demonstrate which shapes are found in the set L intersection H. So we need to look at our chart right here and determine what this is telling us. So all the shapes have to be large, so we can circle the large shapes. We've ruled out all these other ones, and they can be hexagonal or they can just be large. So basically for this one, we are making sure that the only shapes that are included in A are going to be large and hexagonal. And that's really all there is to this. There's not really any work to do, but we just know that this means what we've circled here. So now we're going to start over. So we've done A. We know that A means large and hexagonal shapes intersecting each other. And now moving on to B, it says demonstrate with shapes are found in the set C union H. So if we go back to our instructions, we know that C means circle and H means hexagonal. So we know that it has to be circled or it has to be hexagonal. So that includes everything except for these triangles. So that's all there is to it. The circles that can be hexagonal. Yeah, the circles that can be hexagonal. Sorry for the sloppiness. And like I said, A is large, hexagonal. So now we can be done with that one because we've already determined that for B, the shapes have to be circles or hexagonal. Now, it doesn't matter what color they are, and yet we're going to get to that. But again, this one's just saying for A, it can be large and hexagonal, it doesn't matter what color. For B, it can be circles and hexagons, and it doesn't matter the color either. So, moving on to C. Demonstrate which shapes are found in T intersection R. So the R would mean red, and the T would mean triangles. So what this means is that it has to be when we look at the T up here, it means that it can be all red shapes. So that is these shapes, but it cannot be triangles. So red, not triangles. So now, moving on to our very last one. So let's demonstrate which shapes are found in the set C intersection S intersection R. So these are going to be circles that are small, and they have to be red based off of our letters here. So they must be only circles that are small and red. So that only gives us this right here. So now we've done all these. And this seems kind of self-explanatory, but really it's just teaching us how to look at these unions and intersections and determine what they're going to be. So now, for number 3, it says solve based on the chart given. And this is just the chart. The next slide is going to be what we're actually going to solve. So I'm going to be referring back to this, so don't worry. So these are Indo-Arabic numbers. These are represent numbers. And so all we're doing here is we're just, each of these characters here, a number is represented by them. So what we're going to do is we're going to refer back to our chart, and we're going to add those numbers up. And then we're going to get an answer. So it's not too hard. The only thing we have to do is just make sure we refer back to our chart. So for A, let's go ahead and refer back to our chart. We see here we have these symbols at the very beginning that look like straws. So this means 10,000. And how many of them do we have? Well, we have 3. So we're going to do 10,000 plus 10,000 plus 10,000. Okay, so we've got that out of the way. Now we're going to look at these upside down U-shaped symbols and see what they mean. Well, we can see from here that they mean 10. So how many of them do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now we're going to add 10 5 times. 2, 3, 4, and 5. So now we just have these little sticks left. And I guarantee you they're going to mean 1. Yes, they mean 1. So we have 4 of them. Plus 1, plus 1, plus 1, plus 1. So this is definitely something to put in the calculator, or you can just do it in your head, like I said before. But when we add all these together, we get a very large number, and that number is 30,054. 30,054. So that one was pretty easy, right? Trying to make this smaller so we have more room for the next one. 1, 2, 3, 4, 5. I just keep messing up. I don't know why. This pen is not my friend today. Okay. So the next one is Roman numerals, which some of us are pretty familiar with. So we're going to go back and we're going to look at what we have. We have M and we have two of them. So let's just go ahead and see. And M is 1,000. So we're going to do 1,000 plus 1,000 since we have two M's here. And now let's see what C stands for. C stands for 100. So we only have one, so we're just going to add it once. And now we're going to do X. There's 3 X's, and they mean 10. I mean, some of y'all probably already know this, but we're just going to refer back to it just for the sake of everybody else. So there's 3. So we're going to do plus 10, plus 10, plus 10. So now we're going to see what V means, and it's 5. And we only have 1, so we're going to do plus 5, and then we have the 1, so we're going to do plus 1, plus 1. And once you add all that up, you are going to get 2,137. So that's a pretty big number too. But again, this is just teaching us how to look at a symbol and look at our chart and refer back to it and be able to add all these numbers correctly. So the next one is a little bit easier. There's not as much going on because, as we can see here, it literally just the exclamation looking one and then the arrow. This one means 1 and the arrow means 10. So that one's not too hard for us to do. So here we see we have 1, 2, 3, 4 10s. So that means we're going to add 10 4 times. 10 plus 10 plus 10 plus 10. And then we know that this means 1, so we're just going to do 1. And that equals 41. And that's going to be our answer. So our very last one is this series of all these long horizontal lines with dots. And we can go back to our chart and see what those mean as well. So let's go here. It's a little bit small, but this is our first one. So we know that this is 5, and I already have them written down on my paper, but again, you can just refer back to this chart. This one is 6, and this one is 3, and our very last one is 17. As you can see here, that's the 17, that's 6, that's the 3. So now we have everything accounted for, and all we have to do is add. But it also says that what we have to do is multiply each number by these numbers. So when we do this, we know that, okay, I was wrong. We don't have to actually do this. So if we add all these together, 6 plus 5 plus 3 plus 17, we get a total of 31. Okay, moving on. Demonstrate lattice multiplication. So when we multiply, we would do 28 times 32. Well, another way to do it where we can see everything a little bit better is to use a table. So when we're doing this, what we're going to do is we are going to do 28 times 32. So when we're doing this, what we're going to do is 8 times 3. 8 times 3 is 24. And then 2 times 3. So just to show, we've done 8 times 3, and now we're going to do 2 times 3. So 3, 6. So 3 times 2 is 6. But when we write it, we can't just have nothing here. So we're just going to put a 0 because it still means 6. Okay? So now what we're going to do is we're going to do 8 times 2. We're going to go down here. 8 times 2. And I'll erase those so it's not confusing. 8 times 2 is 16. So we're going to put it here where it belongs. And then we're going to do 2 times 2. 2 times 2, which is 4. And again, we can't have this blank, so we're going to put a 0. And now, what we're going to do next is very simple. Now, you can see here there's rows. I've drawn these lines here to represent the rows. So we're going to add everything together in the rows. So here we just have 6. There's nothing to add to. And then here we're going to put some plus signs. So 4 plus 1 plus 4. 4 plus 1 plus 4 is 9. And now we're going to do 0 plus 6 plus 2. So that's going to be 8. And so now we're done because that's 0 right here. And so now we see here we have this number that is our ending point. So 896, 28 times 32 is 896. All right, moving on to a little bit bigger one. We're going to do 273 times 628. So we're just going to do it the exact same way that we did before. 6 times 3. Well, 6 times 3 is 18. So we're going to list it here like we were doing. And then 7 times 6 is 42. So we're going to list it here. Now we're going to go to the next column. 6 times 2. 6 times 2 is 12. So we're done with the first row. 3 times 2 is 6. And then 7 times 2 is 14. This seems a little bit light for the background, so I'm gonna start over. And we're gonna do again. 3 times 6 is 6. 7 times 2 is 14. This isn't perfect, but it's demonstrating what we're doing here. And then 2 times 2 is 4. That's what we're going to get the 4. So, oh, wait a second. 7 times, okay, we're good. All right, so now we're moving on to 3. We're going to, the 8 column, we're going to do each number up here times 8. So 8 times 3 is 24. 8 times 7 is 56. And then 8 times 2 is 16. So again, we're going to do just what we did before, and we're going to add the rows together. And I forgot to put one of the other ones here. So we're going to add all these, and then when we do this, we get, so when we do this, we're going to add them all up, and as you can see, I've carried the numbers here and here. So what we're going to get in the end is 1, 4, 4, 4, 4. So our answer is 1,444. So next we have our very last one, and it is 964 times 593. Okay. So first we're going to start out by 4 times 5 is 20. 6 times 5 is 30. And 9 times 5 is 45. So we're done with the first row. Now we're going to multiply each number on the second row by 9. So 9 times 4 is 36. 9 times 6 is 54. And then 9 times 9 is 81. That's kind of messed up there, but we'll get the point. And 9 times 3 is 27. 6 times 3 is 18. 4 times 3 is 12. So now we're just going to be adding. So 2 is 2. We have 1 plus 6. And this line should have been not right here. It should have been more like right here. So what we're going to do is we have that, and it's going to be 8 plus 1 plus 6. I got the lines a little bit mixed up. But what that's going to be is 15. So we have to carry the 1 over here. So now we do 7 plus 1 plus 5 plus all of this, and we get a 6. Carry the 3, carry the 6, and then we get another 6 here, and then 1 here. So now our number is really big. Last one, what we're going to be doing here is the same thing essentially. 4,952 times 243. So we're going to do 2 times 2. We know that 2 times 2 is 4. We can't leave that blank. 5 times 2 is 10. 9 times 2 is 18. And we have 8. So now we're going to move on to 4. 4 times 2, 8. 5 times 4, 20. 9 times 4, 36. 4 times 4, 16. 3 times 2 is 6. 15, 27, and 12. Now it's time to add. So we see here that we get 6. 8 plus 5 is 13. So we're going to have to carry the 1 over here. 7 plus, I should probably change that. I'm gonna write a line here. And so now what we're doing is 7 plus 1 plus 0 plus 0 plus 4, carry the 1. And that's going to be 8, 9, 13. We're going to have to carry another 1 over here. So 2 plus 2 is 4, plus 6 plus 2, and plus all of this, all this added together, when we carry the 1, is going to be, it's going to be 13 again. Whoops. Carry the 1. And then we have 1 plus 6 plus 3 plus 8 equals 20. So we have 1,203,036. That's really big. Okay, finally we're done with that. I know it can be a little confusing, especially with the big numbers, but the key is to take it step by step and to just do it like that. So this is something a little bit more easy. I did not mean to do that. My bad. Okay. Demonstrate rounding to the leftmost digit. Estimate the results of the following expressions that make an exact computation. Demonstrate how you got your results and your estimations. So we're not going to get an exact answer here. We're going to be rounding. So as you can see, when we're rounding, based off of this down here, we look at the number. So if we're doing this number, we look at this number to determine how we're going to round that. And again, so when we do this, we're going to be rounding to the leftmost digit. So when we look at 8, we know that 8 means round up, and 8 is closest to 10, based off of our little picture here. So 883, if we're rounding to the leftmost digit, it's going to be 900. And then for 465, we see the 6 means round up, and it's the next digit after the leftmost digit. It's going to be 500. Divided by 134, and we already know that 3 is the lower number on the lower side of the roller coaster over here. And so this is going to be just 100, since we're rounding to the leftmost digit. So when you do this computation, it is going to equal 14. And if you did it just like this, it's going to equal 10.1. So that's, this is our exact answer. And this is the answer we get when we round. So that's a pretty big difference. Almost 4 big difference. So, but this is just basically showing us how to round and follow instructions. So again, we're gonna do it one more time, another time. I think we have a couple more times after this. So when we do this one, 5, for 5, I'm just gonna leave it the same because it's kind of like in the middle. So we're gonna do 5 times 250 is closest to 300 plus 500. The 2 means to go down. So 500. And then this one would just be 40 because this one means we need to round up. And when we do that, well, a better way to explain it would be that 35 plus 7 is 42, and the 2 would just mean that it would be 40. So we're just going to leave it as 40. And when we do this, we're going to get 50. So this whole thing right here equals 50. No, that's kind of a weird way to word it, but and then if we just did this without rounding, it would be 42.7. So this is the difference in the numbers here. So it's a little bit of a difference. All these are a pretty big difference. And again, we're just doing this to compare. And for our very last one, we have 620 times 430 divided by 293. 620 is closest to 600. Again, we're going to look here. The 2 needs to go down. 4, we look at the 3, means go down again. So it's just going to be 400 times 400 divided by 293. We can obviously tell that's going to be closer to 300. And when we do this, we're going to get 800. And then if we were to do the original problem without rounding anything, we would get 909.9. 909.9. And again, another big difference. Okay, for this last set of problems, we are going to create a chart for each of the following and demonstrate how to perform arithmetic in bases of other than 10. So we're always doing arithmetic in bases of 10, but here we're going to do it in the base of 5. And this seems a little bit confusing, but I promise it won't be confusing once we get started. So what we're going to do is we have all, this is our base of 5, and this is the ones place, the tens place, and so on. So starting out, we're going to determine what each of these are. So we have 125, 25, 5, and 1. So what we're going to do is we're going to use dots to represent each number in these numbers. So we're going to start with 432. And what we're going to do is, 432 we would start here with the 432. But we're going to change that to dots. So what we're going to do is 1, 2, 1, 2, 3, 1, 2, 3, 4. Plus 133, 133, again, changing it to dots. 1, 1, 2, 3, 1, 2, 3. I apologize that these dots are not perfect. But now what we're going to do is very simple. Now, let's make sure we focus, because it was actually a little bit hard to get it's actually a little bit hard to get this if we don't make sure that we determine every single step. So we started out, we have our base of 5, we determine what those are, and we have written the numbers in each place based on dots. So now what we're going to do is we're going to add the dots, and we're going to do 3 plus 2, 3 and 2, and that gives us 5. So we're going to do 1, 2, 3, 4, 5. 3 plus 3 is 6. 1, 2, 3, 4, 5, 6. 4 plus 1 is 5. 1, 2, 3, 4, 5. So now we have the sum of the dots of each number here. So when we're doing the base of 5, we have to group them in 5. So as we can see here, 1, 2, 3, 4, 5, we already have 5 over here. So we're going to circle them. And as soon as we circle the group of 5, we have to move one over. And that represents 5 as well. So just think about 5 little dots in that one red dot I just drew. So now we're going to do another grouping. 1, 2, 3, 4, 5. Move one over immediately. That also represents 5. So now what we're going to do is group these again. 1, 2, 3, 4, 5. Circle. Moving another one over. So what we're going to do now is count the dots that we have left over. Any dots left over. What's a dot? I'm sorry. Okay, so here we start off with 1. Here, there is another 1. And here we see we have these 2. So that's 2. And then here we've already grouped all these. So we have a 0 here. And this is 1,120. So if we were adding 432 plus 133 in the base of 5, this is what we would get. And it is a little bit confusing, I will say so myself. But again, taking it step by step. Step 1, list the base of 5. Step 2, write what those mean. Step 3, we have to do 432, 133 in dots. We then add those dots together, get the sum, group them in 5, move one over immediately, and go all the way down. And then we must go back and see what we have left over, and that'll give us 1,120. So here's another one. When we do this, we are going to do the exact same thing, except we're doing a base of 6. Just like before, we're going to determine what these are. So 6 to the third power is 216. 6 squared, 36. 6 to the first power is 6. 6 to the 0 power is 1. So now let's look at what we have. We have 425 and we have 53. So 425 represented in dots, remember, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5. And now 53. 53 is not as big of a number as 425. So we have to go to the ones place. And we have to go 1, 2, 3, 4, 5, 53. Okay, now remember we're adding these dots here. That's what we're doing. So we're going to do 5 plus 3. And that is going to give us 8. 1, 2, 3, 4, 5, 6, 8. 5 plus 2, 7. 1, 2, 3, 4, 5, 6, 7. And then here we have 4. And we don't have anything here. So what we're going to do is add 1, 2, 3. So we have 1, 2, 3, 4, 5 plus 3. Once we've gotten this, we're going to group them in 6. And I always have to remember, I need to draw my line. This is what we've just added. So again, 425 plus 53 and base of 6. So 1, 2, 3, 4, 5, 6. Move one over. And the circle represents 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's 6. Move another one over. Now, we finally have something to add to this 4. So we should have brought the 4 down anyway. And now that we're grouping in 6, we can't group that in 6. So 4 plus 1 is 5. And what we have left over here is 2. I just realized that 1, 2, 3, 4, 5, 6. Yeah, there is 2 left over after we group in 6. And then we have another 2 here. So 425 plus 53 in the base of 6 is 522. So now we're just doing the same thing, but with subtraction. We're in base of 5, 125, 25, 5, and 1. So 414. I'm gonna start over here. 1, 2, 3, 4. 1. 1, 2, 3, 4. 1, 2, 3. So the first row is 414 and the second row is 43. So now we're going to add them. So 4 plus 3 is 7. 1, 2, 3, 4, 5, 6, 7. 4 plus 1 is 5. 2, 3, 4, 5. And then we're just going to bring the 4 down. So remember, I'm going to start over. I just remembered I messed up. So we are subtracting here. Never forget what we're doing. That just shows you how easy it is. So 1, 2, 3, 4. 4 minus 3, 1. We can't do 1 minus 4. So what we're going to have to do is borrow 1. If we borrow 1 from here and move over here, remember that represents 5, 3, 4, 5. So we have 6 minus 4 is 2. And then here we only have 3. So we're just going to drop that down. And then we're going to be 3, 21. This is subtraction. And so we're doing the same thing as we did before with the dots, but instead of adding them, we're just doing subtraction. So we're going to do that on the next one, and I'm going to hopefully not mess up this time. Again, we're going to do 125, 25, 5, 1. 403 minus 24. 1, 2, 3, 4. 0 there, so we can't write it there. 1, 2, 3, 24. 1, 2, 1, 2, 3, 4. We're subtracting. I'm going to write that over here because last time I got a little carried away and I was going to continue adding. So we can't do 3 minus 4. We just can't do that. So again, we have to figure something out. We're borrowing So we're going to move one here. Which represents 5. And then we're going to take one from here and add 1. So now we have, or no, we're going to add 5. So we had 3, 4. So now we have 8. 8 minus 4. This is what this represents, is 4. And now here we have 4 minus 2. Sorry, the dots are not perfect. And then here, well, we borrowed this one, so we only have 3 here. So 403 minus 24, and base of 5 is 324. And that concludes our lesson. I hope you learned a lot about number theory and computing, and we'll see you next time.